Hi everyone. Today we're going to study graph coloring. Problems related to the coloring of maps of regions, such as maps of parts of the world, have generated many results in graph theory. When a map is colored, two regions with a common border are customarily assigned different colors. One way to ensure that two adjacent regions never have the same color is to use a different color for each region. However, this is inefficient. On maps with many regions, it would be hard to distinguish similar colors. Instead, a small number of colors should be used whenever possible. Consider the problem of determining the least number of colors that can be used to color a map so that adjacent regions never have the same color. We have this example. We have a map here. Analyzing this map, we can say that there must be at least 4 colors to color this map. Here is another map, and in this map, we require at least 3 colors. Each map in the plane can be represented by a graph. To set up this correspondence, each region of the map is represented by a vertex. Edges connect two vertices if the regions represented by these vertices have a common border. The resulting graph is called the dual graph of the map. A while ago, we have the two maps, and then the corresponding dual graphs are here. The problem of coloring the regions of a map is equivalent to the problem of coloring the vertices of the dual graph so that no two adjacent vertices in this graph have the same color. Let's go now to graph coloring. A coloring of a simple graph is the assignment of a color to each vertex of the graph so that no two adjacent vertices are assigned the same color. A graph can be colored by assigning a different color to each of the vertices. However, for most graphs, a coloring can be found by using fewer colors than the number of vertices in the graph. This is now the question. What is the number of colors necessary? To answer this, let's go to the next slide. Let us now define chromatic number of a graph. A chromatic number of a graph is the least number of colors needed for a coloring of this graph, denoted by x of g. This x here is a Greek letter read as chi. So we read this now as chi of g. Let's have example 1. What are the chromatic numbers of graphs G and H below? This is graph G and this is the graph H respectively. Let's begin with graph G. The chromatic number of graph G is at least 3 because the vertices A, B, and C are adjacent and must be assigned with 3 different colors. Say vertex A to be red, vertex B to be blue, vertex C to be green. Now let's color vertex D. D can and must be colored red because it is adjacent to B with colored blue and C colored green. D now becomes red. Now let's go to vertex E. E can and must be colored green because it is adjacent to vertices colored blue and red. So E now becomes green. Let's proceed with vertex F. Vertex F can and must be colored blue because it is adjacent to vertices green and red. So F now becomes blue. Let us now proceed to vertex G. Finally, G can and must be colored red because it is adjacent to vertices green and blue. So G here becomes red. Thus, graph G is now colored with exactly 3 colors. So, the chromatic number of G is 3. In symbol, we write chi of G equals 3. Now let's have the graph H. Graph H is a graph similar to graph G plus an edge connecting A and G. This is the edge. To color graph H, same color pattern can be done as to graph G, except on the last stage where all vertices are colored except vertex G. All other vertices here are now with color except the vertex G. Now, G is adjacent to vertices red, green, and blue. A fourth color, say brown, must be used for G. Here it is. Therefore, the chi of H is equal to 4. Example 2. What is the chromatic number of complete graph K sub n? Remember, a complete graph on n vertices denoted by K sub n is a simple graph that contains exactly one edge between each pair of distinct vertices. The answer here is the chromatic number of K sub n is n, or chi of K sub n equals n. Here's one example. For K sub 5, we can see that for each of the vertex, we have 5 different colors. Example 3. What is the chromatic number of complete bipartite graph K sub m, n? Remember, a complete bipartite graph K sub m, n is a graph that has its vertex set partitioned into 2 subsets of m and n vertices, respectively, with an edge between 2 vertices if and only if one vertex is in the first subset and the other vertex is in the second subset. The answer here is the chi of K sub m, n equals 2, meaning color the set of m vertices with one color and the set of n vertices with another color. We have here the graph of K sub 3, 4, 3 vertices by 4 vertices. We color the first set by red and color the second set by blue.